It's time to speak of chemistry and romance. This is where it gets a little emotional. Okay, we're going to talk about chemical reaction types. There are 5 types of reactions listed on your notes. Your book lists a 6th type of reaction. We're not going to talk a whole lot about it. It's good. So we have synthesis, composition, that's one type, alternate names, decomp, single replacement, double replacement, and combustion. There's also what's called an oxidation-reduction reaction. They're complicated, they're weird. The academic content standards for Ohio say that they are outside the scope of a Chemistry 1 course at this level. I agree. When we get through the real material on the types of reactions, we'll briefly talk about what oxidation-reduction reactions are. I want you to be aware of them. I want you to kind of know what they involve. We're not going to work with them, though. So they're not something I'm going to test you on. But when you get to college chem, you'll hear a lot about them. So I do want you to be aware of them. That's all. Okay. Now is the time to speak of romance in chemistry. Any of you ever been to a dance? Okay, good. You've been to dances? You've never been to a dance? You have homework. So, you've been to a dance. Any of you ever go to a dance with a date? Okay. There's a story in this for you. Anybody here ever go to a dance all by themselves? Good. In my day, we call that going stag. Going solo. Okay, so you've gone to a dance solo. That's good. So, you go to a dance all by yourself. Fun. You have a bunch of friends all show up by yourselves. And you're at the dance all by yourself. And there's that cute someone you've had your eye on since the 7th grade. That's great. And what do you know? And what do you know? They're there by themselves, too. And pretty soon you're kind of looking at them and they're kind of looking at you. And the next thing you know, you're dancing together. It's wonderful. Love's in the air. So yeah, this is good. We have 2 individuals who show up at the dance, and by the time the music stops and the lights come back on, they're a couple. It's so sweet. Okay. Well, interestingly enough, this is a synthesis reaction. So we have 2 individual substances that come together and form a new compound. Rusting is a synthesis reaction. You have pure iron, you have pure oxygen, they come together, they form iron oxide. Formation of oxides are really common synthesis reactions. So there's a list of them there. Formation of magnesium oxide. You're going to do that one in here. The sulfides do it. We've got a couple rust reactions. We can form things like carbon monoxide. So adding oxygen to a pure element is a really common synthesis reaction. Sometimes called composition because you are composing something new. So the key, if you look at the top there, that A plus B equals AB, that's what we call the sort of generic or typical reaction form for a given type of reaction. So we've got our 2 singletons, 2 things that are by themselves. They form a compound. They're a couple by the end of the dance. Okay, would you please? And I'm going to give you the space bar power. Okay, now, this is by far, you're right, this is by far the sadder scenario. So you ever been to a dance with a date? Yeah, well, sometimes you go to a dance with a date, and by the time the dance is over, you don't have a date anymore. So, happy little couple goes to the dance, a fight ensues, and by the time the music stops and the lights come back on, they're not really talking to one another anymore. This happens, sadly. So, in this case, we've got a compound. And it is always a compound that starts a decomposition reaction. You cannot start a decomposition reaction with a single element. It is always a compound that begins this. Something happens and it breaks apart. And typically that something is some injection of energy. So just like with the couple at the dance, you know, they didn't just go to the dance, a happy little couple, and dance the night away and eat some potato chips and drink some punch and break up. Something happened. There's a cause. In the case of a decomposition reaction, it's usually energy. So it can be as simple as physical shaking energy. There are a couple compounds that are not stable, and they're unstable enough that shaking will cause them to decompose. One of the real common ones, though, is heating it up, adding thermal energy, or adding electricity. Remember we said we can take hydrogen gas, oxygen gas, put them in a room together, poof, they're going to form water. How would we break that water down into the hydrogen and oxygen gas? We take two wires, we run them off the terminals of a battery, and pretty soon they start to bubble. And we're going to do this on Monday. I'll have an apparatus set up. I can't find my apparatus right now. It's not all that exciting, but, you know, we get little bubbles. So, bubbles. That's called electrolysis. That's a very specific kind of decomposition, is we get, you know, two little wires start to bubble. There are some specific, there are specific cases of decomposition. The big one that's most interesting is electrolysis of water via electrical current. That's the most common, and we'll talk a lot about that as we go. We're going to stop there for today. So